Late one night, the European Space Agency's Deep Space Network recorded a whisper-thin signal drifting in from the edge of the heliosphere. It came from an object called 3I Atlas, sliding silently past the outer limits of our solar wind. Then, without warning, the signal stopped. No static, no fade, just a perfect cutoff, as if a door in the data had been closed. The antennas at ESTRAC continued to function normally. Solar activity was calm, instruments steady. NASA's Jet Propulsion Laboratory confirmed no atmospheric or magnetic disturbance anywhere on Earth. And yet, almost at that same minute, telescopes watching the object noticed its light flicker. A small but deliberate shift in brightness, a pause that felt like a heartbeat withheld. If nothing broke, and nothing flared, then what exactly had ended? When something enters our solar system from interstellar space, it carries with it a kind of quiet unfamiliarity. Not loud or dramatic, but subtle, as if shaped by a different sun and tempered by a different gravity. When astronomers first spotted 3I Atlas, it was barely more than a slow-moving speck against a fixed field of stars. A dim fragment of reflected light sliding where no known body should be. Its course was long, shallow, and free of the gravitational choreography that keeps our planets dancing in their regular orbits. It seemed to wander through our neighborhood without destination or memory, a passerby from elsewhere. Early measurements suggested something ordinary, a cold piece of frozen dust and ice, perhaps another comet born in the black. But small irregularities crept into the readings. Its brightness rose and fell too precisely to be random, and the faint halo surrounding it, its coma, appeared and vanished in regions where sunlight should have had little effect. Those who noticed wrote quietly in their logs and waited. No declarations, no excitement, just patient observation. Because the point was never to solve the mystery immediately, but to move beside it, measuring gently, speaking softly, accepting the humility that deep space demands. Before we go deeper, take a breath and imagine the sheer stillness between stars, the kind of quiet that hums louder than any signal. Welcome to Science Reshaped, where we explore the stories written in cosmic silence. If this journey resonates with you, subscribe so you won't miss the next descent into the unknown. One question lingered beneath every note. If this traveler came from far beyond, what tale might it bring with it? The first fact about any interstellar object is motion. Light arrives to us as coordinates, tiny dots of brightness fixed against darkness. Night after night, observatories plot those dots until a curve appears, graceful and detached. When the path of 3I Atlas was drawn, it refused every familiar pattern. Its speed was too high, its trajectory too open. It was not looping back from the Oort cloud, nor falling inward along a stretched cometary ellipse. It was simply passing through, guest, not native. This and this alone marks an interstellar visitor. Its orbit never returns. The minor planet center confirmed what early models implied, using readings from Pan-STARRS atop Haleakala in Hawaii and the Catalina Sky Survey in Arizona. The calculated eccentricity, the measure of how far an orbit departs from a circle, was greater than 1. That single number told the entire story. Atlas was not born here. Our solar system is a garden of repetition. Comets dive and return in predictable arcs. Asteroids travel in families, remnants of shared collisions held together by the sun's pull. But a visitor from beyond behaves like a seed caught in a cosmic wind. It crosses a boundary and keeps going, untouched by where it began and untroubled by where it ends. And yet, every motion still carries history. No object travels for eons without scars. As scientists refined the trajectory, tracing it backward through models that account for the slow drift of neighboring stars, a curious revelation appeared. The path led toward no known active system. Instead, it seemed to come from the quiet gulf between gravitational domains, a kind of interstellar sea where few suns exert control and matter drifts for ages in solitude. If 3I Atlas truly originated there, it may predate most planets of our solar system. It might have witnessed stars ignite and fade, crossed the shockwaves of supernovas, and floated through nebulae where new worlds condensed. Nothing dramatic, only immense. Time out there does not hurry. A million years is simply another slow turn. Astronomers described its route as astonishingly stable. No chaotic spin, no erratic tumble, only smooth rotation like an old wheel moving through vacuum. That calm raised quiet curiosity. After so many collisions and cosmic dust storms, how could such steadiness survive? Most wanderers are chipped and scarred, spinning unevenly. But 3I Atlas rotated with a measured grace, as if its mass were arranged in a way that balanced itself. Not proof of design, only the faint signature of difference. Some speculated it once belonged to a larger body, perhaps a moon shattered long ago, or a hardened nucleus of an ancient comet whose volatile ices had long since turned to stone. None of those theories could be confirmed. The only certainty was that this fragment's past was older than our capacity to trace it. Roughly 280 light-years away lies a sparse cluster of red dwarf suns. Some orbital projections point loosely in that direction, not as a definite birthplace, but as a clue in the map of stellar drift. Those dwarfs are dim and ancient, glowing not in bright day, but in eternal twilight. Any planets around them would live in slow, cold light, where change unfolds on geological time. To imagine 3I Atlas born in such a system is to imagine a place where fractures widen by patience, not impact, where ice splits from subtle cycles of freezing and thawing rather than violence. A shard from such a world could drift outward gently, carrying within it the quiet endurance of that environment. If so, this traveler has been moving far longer than humanity has drawn breath. Longer than mammals have walked Earth, longer than continents have known their current form. It may have crossed entire spiral arms, bathed in unfamiliar radiation fields, and brushed the outskirts of stars that have since died. To call it interstellar is not only to speak of distance, but of time itself. And yet, here it is. Close enough for us to catch its reflected light. Close enough for our instruments to falter for 2 silent minutes as it crossed some invisible threshold. There is humility in that coincidence. The object carries no purpose, no message. It simply travels. Our awareness of it is an accident, a brief encounter on a vast road. Still, the moment stays with us. The flicker of a lantern seen drifting down a black river, knowing the river flowed long before we arrived and will flow long after we're gone. The first time astronomers turned their spectrographs toward 3I Atlas, they expected recognition, an ordinary pattern, the familiar signature of frozen water and simple carbon chemistry, repeating itself in another distant comet. Most icy wanderers behave like open books. Sunlight strikes, molecules warm, and the light scattered from them tells a story written in well-known lines. Broad dips in the blue reveal water ice, a gentle crimson haze signals organics. Sharp peaks in the ultraviolet announce the short-lived gases, carbon monoxide, hydrogen cyanide, expanding from a nucleus that has felt the sun's heat before. These are the fingerprints of comets we know. But when the first beam of light from Atlas reached the spectrographs, something felt reluctant about it. The reflection was stretched, thin, and uncertain, as though distance had slowed the language of photons. Even so, through that faint shimmer, a few notes refused to hide. They appeared briefly, then softened, then appeared again. Across a single night, the readings rose and faded, forming no stable rhythm, no consistent signal. It was as if the comet itself were inhaling and exhaling on its own slow schedule. Observatories scattered across the globe confirmed it. Hawaii, Chile, South Africa, Mount Era in the north, each recorded what looked like classic outgassing, yet the strength of that activity wavered. One evening the halo was bright, the next it seemed to retreat into invisibility. No instrument error, no calibration drift. The object itself was changing its voice. In the language of space science, that should not happen there. At that distance from the sun, the solar flux is too weak to thaw buried ice. A comet normally waits until warmth becomes fierce enough to loosen frozen gas. Only then does it grow its luminous veil. But Atlas began that behavior far beyond the thermal limit, in regions where cold is absolute. The model that governed every other comet suddenly failed. The graph no longer fit the equation. When an observation defies precedent, scientists first ask the modest question, what simple thing could we be missing? Perhaps its crust was coated with volatile ices that require almost no heat to sublimate. Ammonia, carbon dioxide, or some exotic interstellar mixture. Or maybe the halo was born not from the surface, but from within, where trapped gas found tiny fissures through which to breathe. In a body rotating unevenly, cracks could open and close like lungs. Each of these hypotheses could, on paper, fit. None felt satisfying. Something about the rhythm of the emission remained alien, disciplined in its irregularity. Then came the absence. Nearly every comet known to us exudes cyanide, one of the most stable carbon-nitrogen compounds in the cosmos. Its spectral spike is so reliable that its absence is treated as equipment fault. Yet in Atlas's spectrum, cyanide was not merely faint, it was gone. Instead, the readings showed elongated carbon chains, molecules that rarely endure outside deep shelter. They survive only when shielded from radiation for eons, protected beneath layers of dust or rock. That suggested a crust so hardened that sunlight had not reached its interior in perhaps hundreds of millions of years. Imagine a surface turned armor-thick by time, beneath which ancient gases still slept. Occasionally, a pulse of internal pressure would find escape, release a faint cloud, and the comet would shimmer for a day before closing again. That slow respiration could explain the odd intervals of light and darkness that puzzled the telescopes. But if such stratified chemistry truly existed, it required unimaginable age to form. How old must a traveler be for volatile elements to separate into layers so stable that they vent only in whispers? Older than the ice caps of Earth. Older than the continents themselves. Perhaps as old as the molecular clouds that birthed the sun. When researchers examined the ratios of those carbon chains more closely, the numbers pointed backward in time. They resembled materials found in cold interstellar nurseries, dense clouds where stars ignite. But the shapes of their bonds were subtly altered, as though radiation had touched them for a heartbeat and then abandoned them to drift in darkness again. The implication was staggering. Atlas was ancient even by galactic standards. At the European Southern Observatory, one scientist described the spectrum not as strange, but as patient. That single word traveled quietly through the community. It captured the sense that nothing about this object hurried. Its chemistry moved at the pace of continents forming, of mountains eroding, of galaxies rotating. To call it slow was inadequate. It was accustomed to time. None of this hinted at intention or message. It simply spoke of existence shaped under conditions our solar system has never known. Every observation repeated the same refrain. 3i Atlas behaved like a thing born under another kind of star. When NASA's infrared telescope facility joined the network, the picture deepened. The infrared readings confirmed that the ratios of carbon and oxygen differed sharply from any body orbiting our sun. They aligned instead with the dust that floats between stars, the raw material from which planets are someday built. Atlas might therefore be a fragment of creation itself, a leftover seed from a planetary system that never finished forming. Not the debris of ruin, but a shard of the beginning. If that interpretation held, the light we were collecting was not merely reflection, it was a record, a timeline etched into chemistry. Every photon carried history older than the Earth. But the brightness that night also carried another layer of meaning. One born not from the object, but from the instruments that watched it. Because at the same moment, the European Space Agency's deep space receivers lost their signal, that fragile spectrum shifted, not dramatically, but enough for the graphs to tilt. Correlation is not causation, yet coincidence sometimes whispers louder than proof. The question rose inevitably. Did the object change as our instruments went silent, or did our silence reveal the change already occurring? The incident drew attention not from alarm but from wonder. Astronomers are accustomed to malfunctions, to noise, to error margins. But to have the universe itself pause with you for 2 minutes felt like conversation, even if reason forbade such thought. When the signal returned, both object and observer were unchanged in data, yet altered in perspective. In the aftermath, the teams compared logs across continents, all matched precisely. No solar flare, no magnetic surge, no interference. Only a brief dark interval that coincided with a subtle alteration in color ratios, an infinitesimal reddening as though the surface had exhaled dust and then stilled again. The event would later be catalogued not as an anomaly, but as unspecified transient, a label that preserves mystery without admitting it. To those who spent nights measuring faint light through air and distance, it meant something simpler. For one fragile moment, a traveler older than worlds changed its tone. Whether by physics or coincidence did not matter. What mattered was that we noticed. The deeper they examined that light, the more it felt like memory made visible. Ancient carbon singing the slow song of its own endurance. No pulse, no message, only persistence. And in that persistence lay the most human of recognitions, that existence itself, when witnessed across such time, becomes its own kind of language. The astronomers called it data. The poets among them called it patience. Either way, 3i Atlas had begun to speak, Not in words, not even in waves, but in the steady refusal to behave like anything we already understood. The moment the signal vanished, it did not fade. It was there, and then it wasn't. No static rise, no interference trail, no gradual fall. Just a perfect, sudden absence. The log from ESA's deep space antenna array recorded the dropout with unnerving clarity. One instant the feed carried the steady telemetry hum. The next it stopped cleanly, as if a switch had been flipped somewhere between Earth and a fragment older than planets. No alerts, no overload. No external event that could have severed it. And yet, in those same seconds, ground telescopes tracking the object saw a subtle change in the reflection of sunlight, a shift in tone, a faint alteration in the curve of brightness, almost imperceptible, but synchronized with the silence. At first, controllers in Darmstadt assumed a routine glitch. Deep space links occasionally hiccup when atmospheric moisture thickens or when the Earth's rotation hides one antenna behind horizon. But the weather across Europe was clear, the signal path unbroken, and every dish in the network, from Cebreros in Spain to Malargüe in Argentina and New Norcia in Western Australia, recorded the exact same gap, beginning at the exact same second, ending in perfect unison. A global silence stitched together across 12,000 kilometers. That coincidence erased the comfort of error. Each station operates independently. Their clocks are synced but not fused. For their data streams to go blank in the same heartbeat meant the cause lived outside the Earth entirely. No solar flare registered. No spike in cosmic radiation appeared in NASA's archives. Even the magnetic monitors, sensitive to whisper-level variations, slept through the event. When the feed returned, it did so flawlessly. No reset, no correction, no packet loss. The carrier wave had never drifted, only the information riding it had gone still. It was as though the line had inhaled and then exhaled, leaving no trace of the breath. 2 minutes, that was all. 2 minutes of immaculate quiet shared across half a planet's receivers. During that interval, the object continued to move. Its rotation, slow, deliberate, carried a different face toward the sun. Photometric readings confirmed a gentle alteration in reflectivity, nothing dramatic enough to interrupt telemetry by itself. Yet the timing aligned so precisely that engineers began to suspect geometry. Perhaps the new orientation produced an angle that deflected or scattered the signal. A momentary mirror in space. Light can behave like mischief. One tilt and the reflection disappears. This idea comforted the analysts. It fit within physics, required no metaphors, but when smaller independent telescopes kept their own observations running, their data showed no corresponding dip. They saw the object's light uninterrupted. Whatever silenced the array had touched only the listening network built for precision. ESA's deep space system doesn't merely watch, it listens. It filters faint radio murmurs buried a hair above cosmic background noise, reconstructing patterns almost lost to entropy. Its sensitivity is both gift and curse. A whisper too perfect can overwhelm it. 7 seconds before the data vanished, an odd thing occurred. The carrier frequency tightened. Engineers later described it as stability refinement, a narrowing of variance, as if the signal had momentarily become more exact than the instruments themselves. Then the stream ceased. No sputter, no fade, just a clean zero. Precision first, silence after. The sequence unsettled even the most pragmatic scientists. A chunk of rock and ice cannot decide to sharpen a waveform. A rotating shard does not respond, and yet physics often mimics awareness. Irregular reflections, diffractive interference, phase shifts in a rotating shell. These can look intentional, even when they're simply coincidence wearing symmetry's disguise. Still, the silence lingered in their thoughts because of its perfection. Errors are messy. This was surgical. Each subsystem, the converters, the amplifiers, the buffers, reported nominal. Every clock remained in sync. No component had failed. When they replayed the telemetry, every log agreed, nothing broke. One engineer, after staring at the unchanging console for hours, wrote in his notebook, "It wasn't malfunction, it was absence." Absence is harder to explain than noise. The review team spent weeks building scenarios. Perhaps a rotating reflective plane on the object acted briefly as a shield. Perhaps a microscopic alignment blocked line-of-sight emissions. Perhaps the coma, a haze of charged dust, momentarily scattered the beam. All possible, all unsatisfying, because none predicted silence across every station simultaneously. and yet the pattern refused melodrama. When the signal returned, it carried no residual echo, no distortion, as if the instruments had simply paused their heartbeat and resumed. Only one measurable difference appeared, a mild change in the object's spectral slope. The reflected light now skewed slightly redder, hinting that a layer of fine dust had lifted away, exposing newer material beneath. The surface had changed, barely but measurably. The silence, it seemed, had marked a transformation. During internal briefings, the scientists agreed on a phrase that balanced caution with wonder: unexplained coincidence of optical and radio variation. It satisfied the report. It explained nothing. Still, curiosity refused to quiet, because, as one analyst noted, before the silence came a pulse. In the final seconds leading up to the dropout, the signal amplitude rose in 3 gentle arcs. No sudden flare, no sharp crest, just 3 measured increases separated by equal intervals. Each peak modest, graceful, then gone. Across ESA's stations, the pattern was identical. Even 2 university-run observatories and 1 amateur radio array caught the same faint rhythm, half drowned in static, but undeniably present. 3 breaths, then stillness. The engineers replayed the waveform stripped of processing. Without filters, it sounded almost alive. 3 inhalations, 1 exhale. They knew better than to romanticize noise, yet the image persisted. The pattern was too smooth to be random static, too gradual for cosmic ray interference, too consistent across locations to be equipment fault. NASA's Jet Propulsion Laboratory issued its summary in cautious language: non-random coherence within expected reflectance variability. It was the bureaucratic way of saying, something real happened, but we can't name it. Could rotation explain it? Possibly. A tumbling body can expose alternating bright and dark surfaces, creating a rhythmic pulse as light reflects differently. But the interval of the waveform was shorter than the known spin period. The math disagreed by a clean margin. Whatever the pulse represented, it wasn't merely rotation. Could jets of vapor have escaped in bursts, catching sunlight at just the right angle? Maybe, but gas eruptions are chaotic. They flare and vanish irregularly, leaving messy tails. The recorded peaks were elegant, evenly spaced, calm. Natural processes love asymmetry. This was symmetrical. Even the skeptical began to feel the strange poetry of the numbers. 3 rises, then perfect quiet, followed by resumed normalcy, like punctuation in a sentence written by physics itself. No one dared to claim meaning. They only measured and described. Because science is not faith, it's discipline. And yet, behind the data sheets, a quieter question circled the room. What are we truly witnessing when absence itself behaves like design? In the days after, high-speed simulations attempted to reproduce the event. None succeeded. No model could create the same clean silence without breaking the rules of probability. Somewhere between reflection and resonance, between light and radio, something had aligned for those 2 minutes and then undone itself. When the event was finally logged into the mission archive, its classification code was simple: transient E. The description below it read, "Signal interruption of unknown external correlation." It joined a catalogue of mysteries the cosmos leaves like breadcrumbs, each precise enough to measure, too rare to repeat. To the public, nothing remarkable had occurred, but for those awake at consoles that night, the 2-minute stillness felt like the universe turning its head, meeting our gaze, and just for a heartbeat, breathing in. When engineers replayed the raw waveform from 3i Atlas, they heard a quiet rhythm embedded in the signal: 3 measured rises in amplitude, spaced with surgical precision, followed by complete stillness. It wasn't noise. It wasn't distortion. It was too calm, too orderly. The amplitude swelled gently. Up, pause, up again, pause. A third lift, and then vanished into a faultless flat line. No echo, no decay. It was a gesture so subtle that only instruments designed for cosmic whispers could have caught it. Across ESA's network, the pattern matched perfectly. At Cebreros, Malague, and New Norcia, the same trio of pulses appeared, their shapes indistinguishable. Independent observatories, half a world away, also reported a mirrored tremor in their optical data, so faint it barely rose above the noise. 3 breaths identical everywhere, then nothing. No one called it a signal. The term would have implied intention. Instead, in the official record, it became a transient modulation in reflected amplitude. The phrasing was precise and empty, designed to keep curiosity inside scientific boundaries. Still, late in the night, the scientists listening to those recordings couldn't help feeling as if they were hearing the universe breathe. Deep space telemetry is the domain of mathematics, not emotion. Yet when the wave was stripped of its digital scaffolding and played back through speakers, it sounded like life. 3 inhalations drawn through light years of vacuum. What could produce such order without motive? Rotation was the simplest candidate. As an object spins, bright and dark facets pass through sunlight, and the reflected intensity oscillates. But when the data were compared to the known spin period of 3I Atlas, the intervals refused to align. The pulse was faster, too fast to be rotational geometry. Could jets of vapor erupting from the surface have caused it? Comets vent gas as they warm, and those bursts can create short-lived mirrors of ice crystals. But those events are chaotic, uneven, violent. They stutter, they do not keep time. Atlas's pattern was smooth as heartbeat, deliberate as metronome. Another hypothesis rose and fell just as quickly. Internal fractures opening and closing as the body flexed under heat. That could, in theory, create intermittent reflections. Yet fractures rarely heal themselves within seconds, and none repeat thrice with identical spacing. Natural phenomena, however, have a habit of echoing symmetry without reason. Saturn's rings ripple in near-perfect waves sculpted only by orbiting moons. Pulsars blink in rhythm dictated by their spin, not by thought. The cosmos is full of order mistaken for intention. Still, 3 perfect pulses struck a chord in the human brain that evolution has tuned to patterns. One astrophysicist noted quietly, 3 is what feels designed. It was not a conclusion, only an admission of instinct. Analysts measured every variable they could think of. Frequency spread, coherence, phase, amplitude, slope. Nothing betrayed artificial origin, yet nothing collapsed neatly into the random. NASA summarized it in language polished to avoid poetry. Observed coherence within expected reflectance variability, causal mechanism indeterminate. In plain words, we have no idea, but it was real. The mystery deepened when they overlaid the timing of the pulses with the exact moment telemetry ceased. The third and strongest rise ended precisely as the silence began. It was as if the act of reflection and the pause of communication were the same phenomenon seen from 2 sides. When the link returned, the object's brightness curve had changed. Its spectrum reddened fractionally. The coma, its halo of dust and gas, had thinned. Something had shifted in that tiny interval. Whether coincidence or consequence, no one could prove. Later models suggested that the surface might have shed a fragile crust of reflective material, exposing darker layers beneath. That shedding could have produced the triple flash, a bright layer fracturing and falling away in 3 smooth stages. A cosmic exhale. Imagine a body that has drifted untouched for hundreds of millions of years, its skin hardened by cold and radiation. As it crosses into the faint warmth of a new star, tiny changes in temperature ripple through its structure. Pressure builds within ancient pores. Then, with perfect calm, it releases that tension, not explosively, but gracefully. 3 soft breaths of dust returning to space. Afterward, the surface settles, rebalanced, quieter. That story fits physics, and therefore comforts us. Yet part of science is acknowledging when comfort masquerades as certainty. Because even if this explanation were correct, the symmetry of the event still refuses to feel accidental. Everything about it was too composed. When colleagues gathered to review the event, the room held more silence than speech. Someone projected the raw signal on a wall. 3 rounded humps, bright white against a field of black. It looked oddly like a pulse monitor, or like distant mountains seen through haze. At that scale, the noise disappeared, leaving only shape, pure and simple. Shape that whispered rhythm. Could a reflection do that? One asked. Could resonance? No one answered quickly. Physics provides many ways for order to appear without intent, but few ways for it to feel alive. That night, no one said the word message, but everyone thought it once. Days later, when the debate cooled, the consensus settled on the smallest truth available. The pulse was real, its cause unknown, its repetition unrepeated. For all the weeks that followed, telescopes listened again, hoping for another pattern, another hint of cadence. None came. The silence had been singular. But what it left behind was deeper than noise. It left humility. Humility that even in a universe governed by equations, events still occur that balance perfectly between chaos and meaning. If the triple rise had been random, probability should scatter its timing. If it had been systematic, it should have returned. It did neither. It existed once, then ceased. Perhaps that is the truest reflection of the cosmos. Singular moments of perfection that never repeat. As weeks passed, the object continued its arc around the sun. The pulse remained only as data, 3 tiny swells in a sea of numbers. Yet to those who had watched it live, it felt less like information and more like a breath taken by the universe itself. In their notes, one researcher wrote a final line beneath the graphs. 3I Atlas did not speak. It simply reminded us that silence, too, has structure. The first sign that 3I Atlas would not obey our expectations came from a veil, thin, luminous, and inconsistent, far from the sun, at ranges where most comets sleep beneath armor-thick cold. Atlas began to shed a faint halo of gas and dust. Then it stopped. Hours later, or days, the halo returned, delicate and brief, as if the nucleus were breathing in a room without air. In our solar system, comets keep a rhythm set by heat. Near the sun, energy rises, buried ices sublimate, vapor drags dust outward, and a coma blooms. Farther away, the coma contracts as the nucleus cools and seals. The pattern is imperfect but predictable, a dance of distance, orientation, and temperature gradients that repeat over long, cold orbits. Atlas would not dance. It shimmered before the warmth should have reached it. It glowed faintly after passing the expected heating zone. The timing refused the thermal curve. Whatever governed that veil did not begin with sunlight alone. No alarm sounded. No press release followed. Instead, the anomaly lived quietly in observatory logs and cautious conversations. Scientists are patient. They wait for behavior to persist before they grant it a name. But the on and off cadence, irregular yet returning, soft yet certain, asked for attention. One answer offered itself: supervolatiles. If the surface hosted ices that evaporate at extremely low temperatures, nitrogen, carbon monoxide, ammonia hydrates, then outgassing could begin in the deep cold. Such materials are known, and their presence would explain an early coma. Yet as Atlas drew nearer, the expected surge never arrived. Instead of strengthening, the emission softened. The curve bent the wrong way, so a second idea stepped forward. Structure. Perhaps fractures ran through the nucleus, opening as rotation brought stressed seams into weak sunshine and closing when a hardened facet turned back into shadow. Brief venting would then mimic breath. This accounted for the object's modest rotational shifts, but not for the nature of the dust, because dust tells stories. Sharp splinters betray fresh violence, rounded grains speak of time. In Atlas's halo, the particles were fine and consistent, as though sifted by ages of gentle abrasion. Not shards from sudden breakage, but powder worn smooth by endless micro-collisions in dark space. Old dust, patient dust. If the dust was ancient and uniform, then the coma was not the residue of eruptions, but of release. Something that had been preparing itself for a very long time. Another line of thought emerged at the margins of these discussions, grounded not in metaphor but in the slow physics of ice. Under deep cold and low gravity, certain ices become amorphous and porous, a foam with microscopic cavities that trap gases. Over millions of years, those cavities can restructure, inch by inch, in response to changes too subtle to register on human timescales. Warm them slightly, and the cavities expand. Cool them, and they contract. In such a material, activity might respond not to temperature, but to the change in temperature, to slope, to gradient, to becoming warm rather than being warm. A world of difference hides in that distinction. Warmth is a state. Warming is a story. If Atlas carried an interior of slow-growing lattice, pockets, channels, and threads of ancient ice, then the veil around it might have been the visible trace of transition. A structure adjusting to a new environment after eons of constancy. Not a flare, not a jet, but the soft rearrangement of matter that remembers another sky. There was more. The timing of its brighter veils aligned, not perfectly but persuasively, with a region of the heliosphere where solar wind density fluctuates. Charged particles, striking a small, delicate surface, can lift dust electrostatically, loosen grains, and nudge them free. On large bodies, the effect is negligible. On an ancient fragment whose skin is held together by cohesion as much as gravity, the effect can matter. Dust may cling, then fall. A halo may breathe without heat as its metronome. Even so, the data pressed back with its usual discipline. Random solar wind turbulence should leave chaos. Atlas offered arcs. The rises and retreats, even when modest, seemed to echo a rhythm. Activity building, stabilizing, and fading in curves that looked almost like the triple swell embedded in the radio waveform days earlier. Not a match, not a message, just a principle mirrored in different registers. Language tightens at such borders. Scientists resist the word pattern until they must use it, and even then, they set it down gently. A pattern need not mean intention. A rhythm need not imply mind, but rhythms still deserve to be measured. If the coma is the surface's announcement, then the surface is the interior's diary. Certain minerals formed in deep cold can undergo astonishingly slow phase shifts, releasing trapped gases as their microstructure refines. On scales of millennia, such processes feel static. On the scale of hours, they can appear as breath. If Atlas is built of this kind of memory, ice that flows like rock over minutes and rock that flows like clay over ages, then the halo we saw may be the echo of an interior still settling from environments long left behind. Imagine drifting in perfect dark for 100 million years, so cold that motion becomes patience and patience becomes form. Then imagine a change so slight it would count as stillness by any human measure. A whisper of light, not heat, the gentlest slope of radiation. Within the porous lattice, cavities feel that slope and shift. Some join, others collapse. Pressure redistributes. A seam opens. A seam closes, and a dusting of grains lifts away like fine snow in windless air. From Earth, that looks like a comet deciding to breathe where it should not. From Atlas, it is only physics remembering. This explanation is elegant and incomplete, which is to say, it belongs to real science. Because the halo did not only answer to gradients of light, it also stirred in those regions where charged particles gathered like thin weather. Two clocks, illumination and wind, ticked near each other without locking. The veil rose when either changed fast enough, not when either was simply high enough. A subtlety difficult to prove and harder to model, but consistent with the object's stubborn refusal to follow the ordinary. The duality invited a further, more contemplative inference that remained carefully unstated in formal reports. Perhaps continuity governs Atlas. Not life, not will, continuity. A process that unfolds through time, slow enough to appear static until the universe nudges it and the body answers with a sigh. From that vantage, the coma is not eruption, but response. Not a message, but a consequence. It is the visible fringe of a structure that has adapted by duration. Ice, dust, and ancient chemistry arranged into balance by ages so long that instability has worn itself smooth. If that is true, then the veil around Atlas is less a symptom than a memory trace. Each breath of dust is a footnote on how the object was made, and unmade across distances we count in light, and decades we can barely name. We are not watching a thing break. We are watching a pattern persist, and persistence explains another puzzle. Coherence without strength. How does a fragile traveler remain whole through radiation, tides, and the shake of outgassing? Not by being rigid, but by being in balance. By allowing every small change to distribute itself across the whole. So no single stress decides the fate. Glaciers endure this way, dunes migrate this way, galaxies turn this way, holding their shapes not by resisting motion, but by sharing it. In that light, the halo's irregular regularity makes a different kind of sense. Rising and receding, it preserves the body by letting go, shedding when pressure grows, quieting when equilibrium returns. The coma becomes not decoration or accident, but a mechanism of survival expressed as beauty. This is how the universe often hides its laws, in phenomena that look like poetry until the numbers reveal the prose beneath. Nothing in Atlas requires myths. Everything in it invites attention. By the time the veil thinned again, the teams had stopped asking whether the object was active or quiet. Those were the wrong words. It was responsive. It carried within it a long, slow conversation between interior structure and exterior change. We arrived merely to overhear a few lines, which brings the question inward once more. If the coma reflects the interior, what does the interior reveal about the place that formed it? A world that shapes ice into memory, dust into patience, balance into persistence. What sky did it grow under, and how long did that sky last? The further 3i Atlas traveled, the clearer it became that its mysteries would have to be solved from within its light curve, not from its tail. Every turn of that reflected beam carried the ghost of rotation, the imprint of mass arranged invisibly inside. If the surface veil was the body's language, then the rhythm of its spin was its grammar. Precise, repetitive, quietly eloquent. Telescopes tracked that rotation with the persistence of heartbeat monitors. Each night's sequence was stitched into the next until a full pattern emerged. Atlas turned slowly, once every 16 hours, give or take a margin small enough to impress and small enough to trouble. Too even for a fragment that old. Natural shards wobble. Collisions leave them asymmetrical. Yet the photometric curve traced a line of almost perfect symmetry. Rising, falling, rising again with the grace of a pendulum left undisturbed. From that rhythm, scientists reconstructed a shape, not spherical, not jagged, but elongated, a slender core tapering like an unfinished spindle. A geometry that rotates without tumbling requires balance, a distribution of weight that has survived every gravitational insult the cosmos can offer. That balance, more than composition or chemistry, became the first clear signature of its character. Inside that balance lived a question. What kind of material can keep harmony for billions of years? Ice alone cannot. Rock alone fractures, but a composite, rock fused with volatile minerals, dust glued by ancient frost, can evolve towards stability by losing everything unstable. Over ages, it sheds the pieces that cannot endure until what remains is simply what can. Survival by subtraction. In modeling labs from Arizona to Prague, simulation programs spun thousands of digital twins through the void, testing densities, porosities, tensile strengths. Only those with internal voids, labyrinths of empty space between grains, match the observational data. Solid models spun too fast, fractured, hollow ones precessed wildly. But objects with foam-like interiors, masses distributed through channels rather than blocks, kept the serenity that the light curve demanded. Atlas, they concluded, must be a porous monolith, a paradoxical phrase meaning strength by emptiness. That realization redefined everything observed earlier. A porous interior explains the slow release of gas, the softness of the halo, the triple pulse of shifting reflection. In such a world, stress travels like sound through a bell, rebounding, finding paths of least resistance, emerging far from its source. A small fracture near one pole could echo as a flicker in sunlight tens of meters away. If light is the mirror of structure, then the structure beneath Atlas was a map of continuity itself. Microwave radar, beamed outward from Earth in a last attempt to read the traveler, returned faint but usable reflections. They confirmed what the models implied, regions of differing density, alternating layers that could be shells of refrozen vapor or rubble cemented by ice. Not smooth, not random, stratified. Each layer, a frozen chronicle of an epoch the solar system never knew. A fossil built not by biology, but by temperature and time. In those radar echoes, some saw metaphor, others geometry. The internal boundaries looked concentric at first, then folded, like petals pressed flat. Perhaps they were shock traces from an ancient collision, ripples of compaction frozen before they could fade. Perhaps they were self-organized patterns, the way minerals crystallize into symmetry when left alone. Whatever their origin, they confirmed the larger truth. This fragment was not chaos adrift, but architecture by endurance. Even its motion through space honored that architecture. Atlas rolled through vacuum with a grace closer to spacecraft than stone. No measurable precession, no nervous wobble, only the slow, dignified turn of an object that has learned balance the hard way. It had rotated so long, it had worn itself into poise. From Earth, that steadiness translated into a strange intimacy. Each repetition of the light curve felt like a pulse shared across emptiness. Predictable, almost companionable. It reminded observers that stability, too, can be a form of motion. That stillness achieved through rotation is the cosmos's oldest trick. When the team plotted every data point from the last month of observation, they found something delicate hidden in the residuals. Beyond the dominant 16-hour cycle, a weaker modulation appeared, barely perceptible, repeating roughly every 4 days. It might have been aliasing, it might have been truth. If real, it suggested a secondary motion, Perhaps a slow oscillation of the nucleus or the flexing of an internal cavity. If so, 3I Atlas wasn't a rigid relic, it was a living equilibrium, breathing through tiny shifts that redistribute its stresses before they grow fatal. To a human mind trained on decay, the concept feels inverted. Endurance by movement, strength by compliance. But nature favors such inversions. Mountains crumble because they resist. Dunes persist because they yield. Atlas seemed to understand this lesson instinctively. That internal rhythm also explained the faint pulse seen in radio data. When a porous object rotates within a variable solar wind, tiny fluctuations in charge build and release along its surface, modulating reflection. 3 slow waves of charge relief could easily create the triple rise detected earlier. Nothing mystical, just the beauty of physics executed perfectly. Yet understanding does not erase wonder. The very perfection of the alignment, the fact that 3 breaths of static could coincide with the instrument's silence, remained the kind of coincidence that humbles certainty. The universe is old enough to choreograph irony. As Atlas moved beyond Mars's orbit, its light softened. Spectrographs lost detail. The halo thinned to invisibility. Only the rotation curve persisted, an unwavering metronome receding into faintness. It would continue turning long after our instruments fell below sensitivity, long after our species had archived the data and moved to other questions. Out there, a quiet spindle would keep rotating, slowly equalizing itself against eternity. Before the mission logs closed, one entry, anonymous, buried between technical notes, summed up the mood that hung in the control rooms. Its interior may be foam and void, but the pattern is unmistakable. It endures by sharing its weakness among all its parts. Maybe that's what stability really means. For the scientists, that sentence needed no citation. They had glimpsed an object that taught by existence, how to remain whole, not by resisting change, but by folding it into one structure. The last radar ping returned at the limit of detection. The echo was faint, stretched, but pure, an extended note trailing into silence. No new anomalies, no pulses, no interruptions. Just the echo of equilibrium receding beyond reach. In that final transmission, the data contained nothing extraordinary, and therefore everything essential. A reminder that the cosmos writes its lessons quietly, that sometimes the most eloquent voice is one that simply continues to turn. To understand 3I Atlas, one must trace motion backward until it stops making sense. Not motion in space, but motion through time, through the histories of stars whose light has already aged past usefulness. Every object carries an ancestry written in its orbit, and Atlas's path pointed not to a family, but to solitude. When its eccentricity first exceeded 1, that single digit rewrote the narrative. A hyperbolic traveler does not belong, it passes, but the direction of that passage, the vector through which it entered our planetary plane, hinted at a birthplace among the ungoverned spaces between stellar neighborhoods. Not from any known system, not from an ejected planetesimal we could name, from a place that has no address. Running the orbital mechanics backward through computational models, scientists saw the line of travel extend across the local interstellar cloud, skirting the periphery of faint red dwarfs and evaporated clusters. None fit the trajectory. The most probable origin lay inside an inter-arm void, a vast gulf between 2 of the Milky Way's spiral arms where matter is thin and time seems thick. Out there, gravity loosens its grip, and debris from long-dead systems drifts without agenda. If Atlas was born there, then its first inheritance was stillness, a region where collisions are rare and speed dissolves into patience. Bodies that form in such equilibrium learn endurance, not by strength, but by lack of disturbance. They freeze clean, they spin slow, they persist. They become witnesses rather than participants. The spectroscopic data supported that notion. Its mineral ratios, rich in carbon chains, poor in volatile cyanides, matched samples of primordial dust grains trapped in meteorites found on Earth. Those grains predate our sun. They are the unburned ash of other generations of stars. Atlas, too, seemed to be built from that residue, a handful of stellar leftovers pressed together and forgotten in cold exile. The more researchers compared the numbers, the more improbable its serenity appeared. No trace of fusion products, no metallic oxides heavy enough to betray the proximity of a young star. Whatever system had once claimed it must have dimmed long ago, its energy exhausted before its debris could coalesce into proper worlds. Atlas might therefore be a relic of failure, the embryo of a planet that never happened, the fragments that never met. Failure, in the cosmic ledger, is a kind of purity. Nothing within such bodies remembers violence. They orbit nothing, obey nothing, drift in perpetual rehearsal for creation that never arrived. They are potential preserved in amber. As Atlas slipped closer to the sun, that potential met consequence. The inertial serenity of its past collided with the dynamic gravity of our present. Dust that had not moved for eons began to tremble. Gas that had slept for ages found a gradient to follow. The still object began to whisper activity not because it sought change, but because change had finally found it. That whisper, the coma, the triple pulse, the perfect silence, was the sound of provenance meeting context. Two histories colliding, one glacial, one fevered. For the first time since its birth, Atlas experienced motion imposed from outside itself. It survived by yielding to it, letting the disturbance move through instead of against. In the data analysis meetings, the conversation often circled back to context. Was the calm of Atlas intrinsic or inherited? Did it carry the temperament of its birthplace? Or had it evolved that balance through attrition? In the absence of clear answers, a quiet consensus formed, both. Origin shapes the first note, endurance writes the rest. To illustrate, one physicist displayed a simulation of dust clumps in a molecular cloud. Those that formed near newborn stars flared and shattered. Those far from stellar violence slowly coagulated into steady, porous bodies. Given a few billion years, their rotations synchronized naturally, an emergent calm born of collisions so distant they had ceased to matter. Atlas's even spin, its balanced density, its unhurried trajectory, all matched that model with uncanny grace. It was a body raised in tranquility, hardened by nothing louder than time, and so a different narrative emerged. Atlas was not a messenger, it was a monument, a sculpture left behind by a universe experimenting with patience. In the long pause between starbirths, fragments like it wander, reminders that the cosmos does not only expand in brightness, but also in restraint. When its orbital path carried it behind the sun relative to Earth, observation paused. For a few weeks the traveler was hidden, its data gap another silence layered upon the earlier one. But orbital math continued the story. At perihelion, its nearest approach, the models predicted a mild outgassing. None was seen. The object remained indifferent even to the star that rules us. Temperature rose. Reflection shifted slightly, but equilibrium held. Instruments measured calm where they expected chaos. That quiet defiance taught the observers something essential. Not all journeys are reactions. Some are continuations. Atlas had not come to announce itself. It had simply crossed our path because our orbit happened to intersect its infinity. The meeting was ours, not its. By the time it reappeared from behind the sun, the coma had nearly vanished. Its light curve smoothed, its hue cooled back toward grey-blue. Spectral features normalized. The erratic breath was gone. What remained was rotation and trajectory, steady, unbroken. Whatever process had awakened during its inbound leg had now completed, leaving the object unaltered except for one thing: a film of fresh dust trailing faintly behind it. A trace-like exhalation after a long conversation. In those final weeks of observation, Atlas taught by omission. Every expectation placed upon it dissolved. The silence had not been a prelude. The pulse had not been a pattern. The veil had not been a performance. They were each chapters of a larger stillness, the stillness of matter that had waited since before memory, acting out the simplest rule of survival. Remain in balance and let the universe move around you. For the researchers who had charted its path, the term object felt insufficient by then. It was a narrative condensed into mineral and ice, a proof that serenity could be engineered by time itself. When they spoke of it in papers and meetings, they used careful syntax. It appears, it suggests, it remains consistent. Behind those words lingered a quieter truth that science rarely names aloud: awe. Because the provenance of stillness is not silence, it is comprehension deferred. To understand something ancient, one must slow down enough to match its speed. Atlas did not reveal itself quickly. It asked us to pause, to measure gently, to admit that sometimes knowledge travels at the pace of the object being known. And in that, it may have accomplished what no Discovery press release ever could. It reminded us that the universe's most extraordinary phenomena are not the ones that shout, but the ones that keep their shape long enough for us to learn how to listen. By late March, The object that had carried so many questions was receding again into the cold it came from. The coma had collapsed into transparency. The glow that once painted a soft cloud around 3I Atlas now dissolved into invisibility. On screens and charts it appeared cleaner, smaller, truer to its core. Its light no longer varied beyond the expected rhythm of rotation. The wildness had finished. At observatories across both hemispheres, researchers continued recording out of habit, filling folders with numbers that did not change. Each session confirmed what they already knew. Atlas had gone still. Not dead, not vanished, just complete. Its brief conversation with sunlight had ended, and it was retreating into the dark, pulling the question of its behavior with it. That withdrawal was almost ceremonial. When an interstellar traveler enters a system, it burns itself into our attention. When it leaves, it demands that we look harder just to see it fade. Night by night, exposure times lengthened, signals grew fainter. What had once been a page of brilliant data became a smear of probability against noise. It was difficult not to imagine personality in that departure. We spend months recording a presence, and then it dissolves without explanation, leaving only graphs. But perhaps that is the truest closure any scientist can expect. Not answers, but the calm certainty that the observation is finished. The teams began turning off their tracking scripts. Data centers freed up storage. Observatories moved to new targets. In the official reports, the language was precise, antiseptic. Activity ceased. Rotational and spectral characteristics stable. Object magnitude diminishing consistent with solar distance. But between those lines ran another sentiment, one not written, but felt. A mixture of gratitude and loss. The way one feels when a long study ends and silence takes the seat where curiosity sat. There was talk of future returns, of other interstellar bodies that might follow similar trajectories. Statistically, the galaxy should send us more. But repetition is never guarantee, and some of the astronomers who had watched the 2-minute blackout doubted that such a coincidence would visit again in their lifetimes. Atlas had been singular, not in what it did, but in how it gathered so many forms of stillness into one event. The quiet of space, the quiet of light, the quiet of unanswered theory. Weeks later, as the data archive closed, one analyst noticed a faint residual streak on a composite image from the last tracking night. It wasn't a defect, it was the object itself, still reflecting, still balanced. A spindle of brightness so thin it nearly escaped the frame. He stared at it for a long time before saving the file and writing a simple tag. Persistence confirmed. That phrase became shorthand among the group. Persistence confirmed, the unofficial motto of those who watched Atlas depart. Because that was what the traveler embodied more than mystery or wonder. The principle of endurance without expectation. It had moved through our system untouched by our significance, unaffected by our awe, and yet, by simply existing in our field of vision, it had changed the way we define quiet. One physicist compared it to the residual hum of an instrument left on after rehearsal. You don't notice the note until you turn it off, and the air seems larger for its absence. That was Atlas. The lingering tone of something we were never meant to hear, but did. When ESA's final communique went out, it contained no drama, only acknowledgement. Object 3I Atlas has exited primary observation range. Data collection concluded successfully. No anomalies detected post-2025-0108. Success in this case meant completion. The perfect calm of routine replacing wonder. The silence restored. Still, within that silence, every piece of analysis, the composition, the structure, the breath-like modulation, remained like faint handwriting beneath erased chalk. Each discovery led back to one paradox. A fragment born from the collapse of others had achieved serenity through dispersal, balance through loss. And that paradox mirrored us more than we like to admit. For the engineers and astronomers who had spent those long nights, Atlas became a measure of humility. It was not spectacular like comets that tear the sky with tails. It did not split, explode, or burn. Its significance lay precisely in restraint. In a universe where everything seems to compete for energy, Atlas had taught that equilibrium, too, is an achievement. After its passing, simulations continued for curiosity's sake. Some traced its outbound trajectory for millennia, estimating which starfield it might wander into next. One model suggested it would drift toward the sparse outskirts of the Lyra constellation, crossing open space for hundreds of thousands of years before entering another region dense enough for observation. By then, if any eyes were left to see, they would look upon a body that had once been briefly warmed, faintly changed, and still turning with the patience of something that has already survived too much to care about speed. So ended its story here. Not with noise, not with discovery, but with withdrawal into the comfort of continuation. A body passing back into obscurity after showing for a short while how silence can contain entire dialogues. Those who wrote the closing lines of the ESA summary understood this even if they did not say it. Science avoids poetry, but sometimes data arranges itself into verse. 3 pulses, 1 silence, 1 calm return. The pattern of the universe, written small, and though the instruments no longer listened, somewhere between the stars, a fragment of ice and dust continued its slow rotation. Unaware of names, unbothered by conclusions, content to persist exactly as it had for eons before we noticed. For months after 3I Atlas left the range of direct study, the numbers still echoed through meeting rooms and screens. Not because they promised new findings, there were none, but because the data itself had become an allegory. In the quiet precision of its readings lay a reflection of the very method that made them. The first lesson was discipline. Every event in the saga, pulse, silence, glow, had tempted the human mind toward drama. Yet the instruments, immune to imagination, had done their work without exaggeration. They recorded, time-stamped, compared, and went still again. That is how truth begins in science, not as revelation, but as repetition confirmed. The second lesson was humility. Atlas reminded its observers that most of the universe resists interpretation. No matter how advanced the sensors, there will always be more reality than resolution. The dropout in transmission, the triple amplitude rise, the change in color, all were invitations, not explanations. Sometimes the cosmos answers a question by asking it back. Researchers revisiting those records found themselves drawn to silence as data. They plotted it like a graph, gave it dimensions, and realized it behaved almost like a signal of its own. 2 minutes of unbroken absence that taught more than hours of noise. What began as technical anomaly became a meditation on how knowledge expands through stillness as much as through discovery. When nothing is detected, you learn where the edges of certainty live. In journals and symposia, the event was eventually catalogued under benign titles: Interstellar Object 3I, Atlas, Observation Summary, Thermal Inactivity, Photometric Stability. But among the people who had stayed awake through that night of silence, a different vocabulary endured. They spoke of it as a pause that measured us, not the object. To stare into data so calm that it challenges your expectation of chaos is to confront your own impatience. A third lesson emerged quietly. Objectivity is emotional restraint. Science demands detachment, but detachment is not indifference. It is reverence expressed through control. Every temptation to assign purpose to the triple pulse, every impulse to call it message or breath, had to be resisted in real time. That resistance became an act of respect, because to force meaning onto what simply is would be to break the very mirror we use to see the universe. The researchers noticed that their notes changed tone over the months. Early logs were analytical, phrased like defense arguments: no magnetic surge, no atmospheric disturbance, likely surface diffraction. Later entries softened, pattern consistent, mechanism uncertain, event beautiful in precision. Language itself adjusted to what the data implied, not certainty, but calm acknowledgement. Science, they realized, is not only the act of knowing, it is the art of accepting partial knowledge gracefully. During internal debriefings, one project lead remarked that Atlas had taught them how to stop overfitting. He meant it literally, overfitting models to anomalies ruins analysis. But the sentence carried metaphorical weight. Human understanding overfits life constantly, drawing conclusions from incomplete evidence, seeing patterns in coincidence. Atlas had offered a counterexample, a universe event that refused to yield to narrative pressure. Its elegance lay in not resolving. Beyond the scientific community, the story drifted into popular media for a few weeks, inevitably dressed in words it had never earned. Alien signal, silent probe, cosmic visitor. Then, as always, attention moved on. But for those who had sat through the blackout, the experience had etched itself deeper than headlines. They knew the truth was quieter, that sometimes a signal that stops is telling you to listen to what continues beneath it. Graduate students analyzing the archives found themselves changed by proximity to mystery, handled without sensationalism. They learned that discovery does not always mean more data. Sometimes it means a different posture toward data. In that sense, Atlas became a lesson in epistemology as much as astronomy. What you find depends on how long you can stand to look, without assuming you've seen enough. The mission reports closed with the usual summary of expenditures, observation hours, and results. Nowhere did they mention awe, though it filled every unprinted margin. Awe is unquantifiable, and therefore it hides between numbers, much like Atlas hid between stars. In private correspondence, a senior spectroscopist wrote to a colleague, "The longer I study light, the more I think the universe teaches by withholding, not by giving." Atlas was a class in patience, its syllabus written in gaps. That sentence never entered the record, but it circulated like folklore, repeated in lectures as anonymous wisdom. By the time the following year's observing schedule began, most of the instruments that had tracked Atlas were re-aimed toward nearer targets, asteroids, radio quasars, the usual precision work. Yet many of those same observers confessed, quietly, that the sky no longer looked the same. Where once they had chased spectacle, now they noticed the smaller harmonies, the steadiness of pulsars, the faint thermal drift of moons, the way background radiation hums like a heartbeat too slow for emotion. They had learned to see continuity instead of event. In that shift lay the final lesson. Observation is not conquest, it is companionship at a distance. When humanity looks outward, it does not claim or change the things it studies. It merely witnesses them long enough for their truth to alter us. Atlas had not spoken, but it had reframed the listener. For those who record the heavens, this transformation was almost theological in its simplicity. Every measurement is a dialogue between certainty and wonder, and each must be fluent in both. Precision gives science its backbone, wonder gives it its breath. Atlas had offered a masterclass in that balance. When the final analysis report was filed, the object's name reduced to a catalogue number among hundreds. One engineer added a line to the closing remarks: "No anomalies detected, all systems nominal, insight achieved." A strange coda, neither official nor technical, but no one removed it. It felt right, a human sentence appended to a cosmic equation. Years from now, when data historians revisit the raw telemetry, they will find only numbers, amplitude values, timestamps, spectral ratios. They will not see the faces lit by monitor glow as silence filled control rooms. They will not hear the breath that everyone held when the signal stopped. But if they look closely enough at the graphs, they may notice a gap that hums louder than all the recorded noise combined. That is where understanding began. Not in what was transmitted, but in the space between transmissions. In that space, the observers found themselves reflected, finite minds listening to infinity, humbled by the realization that even absence, properly measured, can be a form of presence. That is the quiet legacy of 3i Atlas, the reminder that science's greatest instrument has always been patience. In the end, 3i Atlas slipped beyond our reach, fading into the dim architecture of interstellar night. Its light grew too thin to trace, its path too straight to remember. The reports were filed, the telescopes turned elsewhere, and the hum of data servers returned to ordinary static. Nothing exploded, nothing revealed. It had come quietly and left quietly, like a tide that never needed a shore. What it gave was not discovery but calibration, a reminder that the instruments we build measure not only the universe, but our ability to wait for it. We learned that silence can speak, that absence can record, that patience can reveal symmetry where certainty sees only blankness. The three pulses, the breath of dust, the perfect stillness, they remain not as mysteries to solve, but as proof that wonder does not require explanation. Somewhere, far past the edge of our influence, a fragment of frozen chemistry still turns, balanced in its own mathematics. Its orbit will never return to us, but its example will. Because every time we point our instruments at darkness, we remember that moment when darkness pointed back and paused. For now, the echo continues, faint but faithful. A single object drifting through the galaxy, teaching by existing, proving through persistence that knowledge and awe are often the same thing, seen from opposite directions. And so the story ends not with discovery, but with understanding that the cosmos does not perform. It endures, and those who listen long enough will find that even endurance has a rhythm, soft as 3 quiet pulses, fading into infinite silence.